acceleration. You're on a planet where you drop an object and gravity is going to cause it to increase at the rate of 40 feet per second every second. So every second it's going to get faster and faster and faster and faster. A through F. A, how fast is it going to be going at 5 seconds? So you go through the table, or you can figure it out just by multiplication. So 0, it's going 0, 1, it's going to increase to 42, it's going to increase to 83, it's going to increase to 120. So all you do is just multiply the number of seconds by 40. So 5 times 40, that's going to be 200 feet per second. B, what's the distance that it will have traveled? Not the total distance, just the distance between 6 and 7 seconds. So if we keep going 6 seconds, it's going to be going 6 times 40, so it's going to be going 240 feet per second. Then 7 seconds, 7 times 40 is going to be 280. So this is just the speed, but we need to know the speed to calculate the distance. Alright, so the distance traveled from here to here in that 1 second that it was in the air. So that 1 second that it was in the air, it started off going 240 feet per second, but it ended going 280. So its speed was changing, it was getting faster. So the distance is going to equal whatever the speed is times the time. But since the speed is changing, and because it was changing at a predictable rate, it was changing at a constant rate, we're going to use the average rate of change, not the lowest, not the highest, somewhere right in the middle. So the average speed, if you're going 240 and you increase to 280, but you increase at the steady pace, it's going to be 260. And now you're going to take 260 and multiply it by the time, and it was only in the air for that 1 second, so it's going to be 260 feet traveled between that 6th and 7th second. Now the total distance, that is going all the way back to 0. So 0, the speed was 0, and at 7 it had increased all the way to 280. Alright, so same thing, we've got to use somewhere between 0, the slowest and the fastest, 0 and 280. So the average between 0 and 280, the average is 140. And 140, you need to use that, that's the speed, 140, and times it by the time that it was in the air, and it was in the air 7 seconds. So the average speed, 140, multiplied by 7 times 7 is going to be 980 feet. Okay, when is this object going to hit the surface of the planet? It says at the beginning that you're 1,000 feet above the planet and you're going to drop it, and at 7 seconds it was 980, so it's going to happen right between 7 and 8. And if I ask on the test, when will this object hit the surface? To the nearest 1,000th of a second. So I might ask you to be more specific than just tell me between 7 and 8 seconds. I want to know exactly to the 3 decimals when does it hit. So let's do E and F first. E, write a model that represents the total distance traveled. Okay, these acceleration, gravity, this follows a quadratic model. Your quadratic is y equals ax squared plus bx plus c. And what we found in these situations, a is going to be 1/2 of the acceleration rate. So a is equal to 40 divided by 2. A is 20. And then b is your initial speed. So our initial speed was 0. It started at 0. But if I would have started it like throwing it, it would have an initial speed. When you start the clock, if the speed is 0, there is no initial speed. But if you start the clock and there's already a speed of 100 feet per second, then it has initial speed. And then c is your y-intercept. That's kind of like the height you're dropping from. So e a formula that's going to give you total distance traveled. So distance equals a x squared. A is going to be 20, so it's going to be 20 times t squared, and time is abbreviated by t, and that's every second. We're measuring time in seconds. So if I want to know 7 seconds, I take 7. I already knew that 7 gave us 980. So I'm going to drop 7 into this model. 7 squared, so it's going to be 20 times 49, and that will also give you 980. There's no initial speed, and I'm not going to drop it from any height. And this model right here will just give me the total distance traveled. Now F, the model for F, we need a model that represents its position above Earth. So this is going to be, starting off, it's 1,000 feet above Earth, and then I'm going to subtract the distance traveled depending on how many seconds it's in the air. So there's a difference between E and F. Okay, now I'm going to use F to find D, and this question shows up like 4 times on this test. So I've got this equation. The distance equals 1,000 minus 20 t squared. Okay, and the question on D is, when is it going to hit the surface of the planet? So it hits the surface of the planet when the distance is equal to 0. So 0 equals 1,000 minus 20 t squared. That 0 will be when it hits the surface of the planet. So now that I see that it's a quadratic equation, I can use the quadratic formula, and the quadratic formula will tell me exactly what time it's going to spit out a 0. So I'm going to erase this stuff. Maybe I'll insert a page. So the quadratic formula. So we got 0 equals 1,000 minus 20 t squared. So my value of my A is 20, B, there's not one, is 0, C is 1,000. So here we go, x equals negative b, plus or minus the square root of b squared, that's just 0, minus 4 times a times c, all over 2a. Okay, now I see a problem. 2a is going to be 2 times 20. A is a negative 20, so a's got to be a negative 20, and that's going to change that to a negative 20, and it's going to change that to a negative 20. Okay, now I think we're good. So I'm just going to type this in on my calculator. I don't really need this, but I need plus or minus a negative 4 times a negative 20 times 1,000. So I got plus or minus the square root of 80 grand all over a negative 40. And if I do this on my calculator, square root of 80 grand, and hit enter, and if I divide that by a negative 40, so one of my zeros is going to be negative 7.07106778. So the calculator is giving me this decimal. If I ask for 3 places, this is what we're after, but this one doesn't really make sense. Negative 7 seconds, so it's going to be the other 0 that I want. It's going to be the negative square root of 80,000 divided by negative 40, and that one is going to be positive 7.071 seconds. So this is when it's going to hit the Earth. So if you're using quadratic equations, use the quadratic formula, punch it in, and find your zeros. 2. Okay, 3 tables here. So let's just do 2 of them. Let's do 2 and 3. And then you can use the same strategy to find 4. Okay, 2. first you need to figure out what family of function they come from. So start breaking down the differences. 0 to 16, that grew, so that's going up. This is increasing. So that increased by 16. 64 to 16, that increased by 48. 144 minus 64, that difference is 80, and maybe just one more. You only really need to do 3 or 4. 256 subtract 144, that difference is 112. Now I know just by looking at it, it's not a linear function, because the linear, the change would be the same every single time, and it looks like the change is getting bigger and bigger each time. So now I'm going to break it down again. The change from 48 to 16, that was 32. The change from 80 to 48, that was also 32. And the change from 112 to 80 was also 32. And this is the feature of a quadratic function. Now I know that it is quadratic because the second time I broke it down, the change was constant. So quadratic, it's got to follow this model, ax squared plus bx plus c. So we've got to identify a, b, and c. And a and c are very easy. A equals this constant change divided by 2. You cut it in half. So our case, a is 16. C is just as easy. C is the y-intercept, just like the b in y equals mx plus b. Here's my y-intercept. C is 0. And now you're 2/3 done. You just need to find b. So b, kind of a cool way to find b is, let's set up an equation and plug in everything we know. We know a, we know c, and let's choose an x and a y. So let's choose 1 and 16. So 1 and 16, 1 is a x, 16 is a y. So let's plug in an x, a y, a c. Because our formula is y equals ax squared plus bx plus c. So in place of this y right here, I'm going to substitute a 16. In place of this a right here, I'm going to substitute a 16 times x squared. In place of the x, I'm going to put a 1. B, there's nothing to put in for b. I don't know what that is, so that needs to stay a variable. But in place of the x, I put a 1. And in place of the c, I'm going to put a 0. So now I'm going to do my 1 squared. 1 times b is just b. 1 squared times 16 is just 16. So now b plus 16 equals 16. So I know b's got to be 0. Minus 16 minus 16, b is 0. So if b is 0 and c is 0, my equation is y equals 16x squared. Okay, now let's look at 3. 3, I believe, has a b. So it's going to be a little bit harder maybe. Okay, this one. You start looking at your pattern and these numbers are decreasing. So they're changing in a negative way. 800 to 770, that went down, so that's negative 30. 770 to 700, that went down 70. 700 to 590, that went down 110. Let's go one more. 590 to 440, that went down 150. Okay, so it's not linear, so let's break it apart again, and it's still going down. 32 to negative 70, that's negative 40. Negative 70 to negative 110, that's negative 40. Negative 110, negative 150, that's negative 40. So it's quadratic. If it's quadratic, it's going to be y equals ax squared plus bx plus c. Okay, now a is easy to find. Just cut that in half. So a equals negative 20. B is the hard one. C is easy to find. C is 800. Okay, now choose x and y, and I always choose 1. So I'm going to choose this point right here. You got several to choose from. Choose 1 because it's an easy number to work with for your x, and your y. Let y be 770. And then I'm going to plug this y in for this y, so it's going to be 770 plug this a in for this a negative 20 times x, which is 1 squared, plus b, don't know b, but you know x is 1, plus c, 800. Okay, now you do the math. That's a negative 20 plus b plus 800, and that is equal to 770. So I'm going to combine these two terms, and that's going to be 780 plus b. So I want b by itself, so I'm going to get rid of the 780. I'm going to minus 780, minus 780. So b is equal to a negative 10. So negative 10 right here. So I got my a, b, and c. That's all I need. My model is going to be y equals a negative 20x squared minus 10x plus 800. And that is it. Okay, and you should be able to handle 4 on your own. The answer, if you want to check it, the answer to 4 is y equals negative 10x squared. I don't think there's a b. Plus 500, so the b is 0. Okay, 5, this is the exact same thing. So it's in a story problem, but it's a quadratic. So the equation d equals 0.05 v squared plus 1.1 v models the distance d in feet that it takes a car to traveling at a speed of v, so v is kind of like the speed, the velocity, to come to a complete stop. So if Hannah's car stopped after 250 feet on the highway, where the speed limit was 65, was she speeding? So this formula right here, the v is the speed and d is distance, and they want you to find the speed based on this distance. So let's take this distance and let's substitute it into our model. So it's going to go in for the d. So it's going to be 250 is equal to 0.05 v squared plus 1.1 v. Okay, now as soon as I see it's a square, I see it's a quadratic, and I can use the quadratic formula. Find a, find b, find c, plug them in, spit them out. Not too bad. So first, in the quadratic formula, everything needs to be on the same side. I got to move this 250 over. So I got a minus 250, minus 250. So it's going to be negative 0.05 v squared plus 1.1 v minus 250 all over, no, we're not all over 2a yet, and that's equal to 0. Okay, now let's find the a, the b, the c. Find a, find b, find c. A is a negative 0.05, b is 1.1, c is a negative 250. So now that I got my ABC, I'm going to plug them in. X equals negative b plus or minus square root of b squared minus 4ac all over 2a, and do the quadratic formula. So x equals a negative 1.1 plus or minus the square root of b squared 1.1, and b squared always has to be positive. So if you don't put it in parentheses on the calculator, if b were like a negative 4 and you type in a negative 4 squared, it's just going to do a negative 4 times 4. It's not going to do a negative 4 times a negative 4, which it should do. It's only going to do that if you put it in parentheses. So if you don't and it's negative, it's going to give you a wrong answer. So b squared minus 4 times a, which is negative 0.05, times c, which is a negative 250, all over 2a. 2 times negative 0.05. Okay. Now, because it's decimals, if you type this in on your calculator, use that little fraction template and hit enter. One with the plus, you're going to have to do it twice. One with the plus and one with the minus. It's going to give you 2 decimals. So 5. A, was she speeding? After you look at your 2 zeros, let me go grab a calculator. Alright, so I grabbed a calculator, plugged it in, and it told me a non-real answer. So I think I found a mistake. I gotta go slower, not write so sloppy. So this is my A, 0.05, and then when I wrote it down, I wrote down A is negative 0.05. So that's going to mess me up. So A should be just a positive 0.05, so I got to change this to a positive, and then this to a positive. So now I just type this into my calculator in the fraction template and hit enter with plus, and hit enter with minus, and my two answers I get are x equals negative 82.56 blah 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 and 60.561 blah blah blah. So negative speed in this context, this one's not gonna make sense, but this is the one I'm gonna use. So the question is, if the speed limit was 65, was she speeding? No. What was her speed? Her speed was 60.561, and if I ask you to go to the nearest 10,000th, you can keep going 1, 6, because your calculator will give it to you. So the quadratic formula will give you the exact speed down to as precise as you want it. Okay, 6 is the same thing. What is the smallest zero, or what is the smallest root, or what is the smallest solution? So move number 1, let's plus 8 plus 8. So I got 3a squared minus 8a minus 60 equals 0. So that means my A is 3, B is a negative 8, and C is a negative 60. So this whole first part of the midterm was quadratics using the quadratic formula. Just kind of plug and chug. So x equals a negative b, so it's going to be negative 8 plus or minus the square root of b. Put this in parentheses. Negative 8 squared is a positive 64 minus 4 times a times negative 60 all over 2 times a. Alright, so let me pause and plug that in and see what it gives. Okay, so I calculated it and I got, for one of my zeros was 6 and the other zero was a negative 10/3, and they want the smallest zero, so the smallest zero is the negative 10/3. So if you can maneuver the quadratic formula, and if you know when it needs to be applied and used, you should do well on these. 7 is same type of problem. 7 though must be done on the calculator. They want you to graph it. Alright, it doesn't need to be, but it's a pretty easy way, because it's asking approximately. If it was asking for exactness, that's a totally different question. But if it's asking for your best estimate, then we can just look at a graph. So 7, Joe kicks a ball in the air. The ball's height in meters can be modeled by this equation. Alright, so how high is the ball going to reach? On your calculator, if you type this into the graph and change these t's to x's, the negative is going to flip it upside down. It's going to look something like this. So your parabola is going to open downward, and if you type it in, I'm not sure what it looks like, but your x-axis, this is in seconds, and your y, because t is time is seconds, the y-axis is going to be h, and this is going to be height in meters. Alright, height in meters, so 1, 2, 3, 4, 5. So type this in your calculator, and then look at the parabola. You can turn the grid on. If you turn that lined grid on, so in the wrench, turn on your line grid, you can zoom in and out. This is actually called the max, and if you, on the calculator, if you go into the tools, if you analyze graph, I think you can calculate the max. So how high is it going to go? 7, if you look at that graph, somewhere approximately 10-ish. So these two little tildes, that means approximately. When is it going to reach its max height? It's going to reach its max height somewhere between 1 and 2, so closer to 1.3-ish. When's it going to hit the ground? Okay, that's here. That's when the height is 0. So it leaves the foot at 0, and then it goes up, and then it comes back down. So 0. That happens approximately 2.7 seconds. Okay, now domain and range. What is an appropriate domain? Domain is the left and right. So what is the farthest left this graph could go? So if you're kicking a soccer ball, the farthest left it's going to go. Negatives don't really make sense. They don't really apply. So we're going to start here and kick it. It's going to leave your foot at 0. It's going to go up. It's going to max out. It's going to come back down. So even though the parabola continues forever, we only care about from when it leaves your foot to when it hits the ground. So your domain, the x-axis is sandwiched somewhere. It's like smaller than, I guess you could say smaller than 3. Smaller than 3, but it's got to be greater than or equal to 0. So from like 0 to 3, if you're using interval notation, include 0, put it in a bracket, 3 is parentheses. Okay, the range up and down. The up and down, negatives don't really make sense here either. So the range on the y is going to be the same. It's going to go from 0 up to 10. Include 0, 10, who knows, unless you calculated exactly the max. So we won't probably be too picky if it's approximately. Okay, now can you find the exact second that the ball is going to hit the ground? So right here. So we guessed from the graph that it's somewhere around 2.7. So the exact, take this formula, it's quadratic, and let's solve it for h equals 0. So plug 0 in for h. So 0 equals negative 5.6 t squared plus 15t. And everything is all ready to go. So I'm going to identify my a. My a is a negative 5.6. B is 15. C is 0. So x equals negative b plus or minus the square root of b squared minus 4 times a times c, 0, that's nice, all over 2 times a. 2 multiplied by a negative 5.6. Okay, I'm going to have to do it twice. I'm just going to type this in my calculator. So open the fraction template, type the top in, type the bottom in, hit enter. You got to do it once for plus, once for minus. So let me pause and do that. Okay, so one of my answers was 0, which hopefully that should be, because that's where you're going to start. And then the other answer is, this is the one we're after. I need to know where it ends. It ended at 2.67857 seconds. So depending on how precise we want to get, the quadratic formula will give it to you as precise as you want it. Okay, Aight. Aight is kind of the exact same thing. They're giving you a quadratic model that represents this roller coaster dropping to the ground. And if it starts 60 feet from the top, so here we are, here's your picture. Right now you're 60 feet above the ground. How long is it going to take you to get to 0? That's what they want. If this drops at this rate right here per second. So h is height. I'm going to take h and I'm going to substitute 0 in for it. So 0 equals negative 16. I'm going to change them to x. This is x squared minus 64x plus 60. And then it's just a quadratic equation. I'm going to set it up and solve it. They want to know exactly when you're going to hit 0. So quadratic formula is a good way to go. A equals negative 16, B equals negative 64, C equals 60. So x equals negative b, so now that's going to be positive 64 plus or minus the square root of b squared minus 4 times a times c all over 2 times a, 2 times negative 16. Okay, so now I'm going to pause it, type it in my calculator. I'm going to get two answers, one for the plus, one for the minus, but this one, one of them is probably going to be negative, one's going to be positive. I'm going to disregard the negative one because how many seconds is it going to take? It's not going to take a negative second. Okay, so I did the calculations and x is equal. One of them is a negative 4.78 and they just only want nearest tenth, so I guess just one decimal. And the other one is 0.78. And this is the one we want, so 0.8 to the nearest tenth is 0.8, so just under a second it takes you to drop 60 feet. Alright, 9. Which one is going to give you complex solutions? Complex solutions happen when underneath the square root you got a negative. So 9, let me look at A. So I'm not going to calculate the quadratic formula all the way through. I'm just going to see which one gives me a negative under the square root, or you could graph them on your calculator, and whichever one does not touch the x-axis, that's the one that has complex roots, because the roots are where it crosses your real number line. So if they never cross the real number line, then they're complex roots. Okay, A is 2, B is a negative 12, and C is actually a positive 18. So under the square root is B squared. 12 times 12 is 144, minus 4 times A times C. So I'm going to do this real quick. 144 minus 4 times 2 times 18. So underneath that square root is 0. So that one is real. Okay, B. A is 10, B is 6, C is 6. So under the square root we got B squared, that's 36, minus 4 times A times C. So 36 minus 4 times 10 times C, I guess that's a 6. That's a 6, and this under the square root is a negative 204, and that is the one that's going to give me imaginary roots because of the negative. So 9 is B. Okay, man, we're about done here. Okay, I'll finish this up. Here we go. What is the factorial form of x squared plus 16? What's going to times and give you x squared plus 16? If you go through them, I think it's got to be C. So let's go through C. X times x gives you x squared. X times negative 4i is negative 4ix. 4i times x is a positive 4ix. 4i times negative 4i is a negative 16i squared. These two zero out. I squared is a negative changes that to positive, so there we go. Now, mine is going to be easier because I have the option to enlarge this, and these are a lot easier to do if they're huge. So, angle number 1. Angle number 1 and 53 are on a straight line, so they're supplementary. They got to add and give you 180. So 180 minus 53. So angle number 1 is 127 degrees. Angle number 3 is vertical to 1, so angle number 3 is also 127. Angle number 8 is corresponding because these lines are parallel. So 1 and 8 are the same. 8 is 127. 8 and 10 are the same. 10 is 127. 2 is the same as 53 because they're vertical angles. So 2 is 53. And Oh, you know what? I'm not sure about this 7, 8, 9, and 10. Because I've got this perpendicular, this vertical line going through where I don't up here. So I might have to erase my 7, 8, 9, and 10. I might have jumped the gun a little bit too there. Okay, so I don't know any 7, 8, 9, or 10 yet, but I feel pretty good about 1, 2, and 3. Okay, 1, 2, and 3 I'm going to lock in. They're good. Okay, now I'm going to start over here. This guy is 90, so 6 is 90. Because they're vertical from each other. Now, I know that 4 and 5, 4 plus 5 equal 90. And I know that 5 is corresponding to 53. 5 and 53 are the same. So I'm going to say 5 is 53. And we are going to say 5 plus 4 is 90. So 90 take away 53. That's going to be 37. So 4 is 37. Okay, now 4 is corresponding with 7. 4 matches up with 7. So 4 is 37, 7 is 37, 7 is 37, 9 is 37. I feel better about these. And then 8 and 10 are going to be supplementary to 7 and 9. So 180 minus 37 is going to be 8 and 9. So 180 minus 37. So these are both 143. Okay, that one's tricky because this third line kind of messes it up, changes things. So I'll go slow, double check. 14. If they're parallel, that means this angle and this angle are the same. And if this is 90, they're all 90. 90, 90, 90, 90. All the way around. So x plus 25 has to equal 90. So one number plus 25 is 90. X has got to be 65. And the y minus 18 has got to be 90. So one number subtract 18 is 90. And that's 108. So y has got to be 108. 15. If these lines are parallel, this angle right here and this angle right here, they're either one of two things. They're either congruent, so they're the exact same, or they're supplementary. They add and give you 180, and these two add and give you 180. So I'm going to take the 5x minus 25 plus the 3x plus 9, and they will add together and give you 180. So add up your x's, that's 8x's, add up your constants, a negative 25 plus 9, that's a negative 16, and that equals 180. So plus 16 plus 16, so you got 8x equals 180 plus 16, 196. So divide by 8, 196 divided by 8. X is going to be 24.5, so don't be afraid of decimals. Alright, last one. 16. This one's going to be easy. Okay, they're parallel, so special things happen. X and 83 add and give you 180. So this has got to be, X has got to be 97. 97 plus 83 is going to be 180. Okay, now if this is 83, so is this, and so is this, and so is this. So the y minus 13 equals 83. So plus 13 plus 13y is 96. Okay, 10 I'm not going to work out. 10 is just a quadratic formula. A is 8, B is a negative 8, C is 7. Plug them in. Find the roots. And this is it. Do you have enough information to declare that P is parallel to Q? P is parallel to Q only if 128 plus this angle is 180. If these two alternate interior or consecutive interior angles add and give you 180, then it is parallel. So I'm going to add the 24 plus the 27, add all those up. And what do we got? 128 plus 24 plus 27. It equals 179 degrees. So it's almost parallel, but it is not parallel. They got to add and give you 180. Okay, P and Q over here. We got this guy right here, 53. And we've got these two right here. So same thing, they're consecutive interior. If these add up and give you 180, so the 53 plus the 37 plus the 90, and the 53 and 37 is 90 and 90 and 90, so this one's yes. But the theorem is consecutive interior angles are supplementary only in parallel lines. That only happens in parallel lines. So if these are supplementary, that means these lines are parallel. Get 20. I think no one missed this. A, 3 and 6. 3 and 6 are alternate interior. 4 and 6. 4 and 6 are consecutive interior. 2 and 7 are alternate exterior. 1 and 5, those are the same location, those are corresponding. 1 and 8, those are alternate exterior.